So, good afternoon. Everything right? Yeah, okay. Say again? Yeah. So, good afternoon. My name is Johannes Büns. Welcome to this session. The session is called Pioneering Solution for Renewable Energy Sources. I work for the EIC, the European Innovation Council. In a very, very short nutshell, what do? We support deep tech in Europe, both on low TRL and on high TRL, to go to the market, to be successful in the market in a certain area, and to bring Europe further. Today, you're going to meet 4 selected EIC beneficiaries from our accelerator program, which is the program for the highest TRL for SMEs and startups. And they're going to explain way better than I ever could what they're doing to bring, in the field of renewable energy sources. We have with here, second person is Andre from C2C NewCap. Then we have Christina from Lixea. Then we have Jakob from Ligna Energy and Nick from Bright Solar. But first and foremost, I would like to introduce you to Francesco Mattiucci, who is a program manager at the EIC. And what that is and what he does, he will explain it to you in exactly 7 minutes. Good luck. One more thing, sorry, I forgot to mention. As I'm German, as you might have known, I have a self-imposed education. We call it Bildungsauftrag, so it's an idea to educate. So we will have a short quiz on the panel after this. Kindly are invited to participate through Slido. It's just for fun. I personally think the questions are quite hard, but maybe if you listen well and you can get 5 out of 5, and then you get a little prize. Good luck.
I agree with Johannes that the questions are quite difficult, so it's challenging. It's nice. It has been done by a colleague of us. That's good. Okay, I use the 7 minutes. Good morning to everybody. And what I will describe is, I will start from saying what Johannes said twice, that is TRL is the acronym for Technology Readiness Level, and it's a scale that goes from 1, that is when you have got an idea, okay, I want to make a new solar panel, I want to make a new battery, okay, that's the idea, and you are at TRL 0, okay. I try to look what I can do. Okay, you move from 0 to 1. Then you go all the steps. When you arrive at 9, your battery is on the market, okay. So the scale goes from 0 to 9. And the second thing that Johannes said is the deep tech. Okay, deep tech is a kind of innovation that is driven by science. So at the end, at the beginning and at the end, it is driven by the knowledge, by a scientific result that then has to move from the laboratory to the fabric, so to the manufacturing, to the market. And this is where the EIC goes in. So what we do, you see here in this slide, is we give help to our beneficiaries, because we are part, and now I will describe on the second one. I go back to the first one if I am able. And now, 3, 2, 1, we go. Okay, here you see this is the Horizon Europe scheme, the structure, okay? This is all our European taxpayers' money. When they have to go inside R&D, they are divided in these funding schemes, okay? You see Pillar 1, Pillar 2, and Pillar 3. In Pillar 3, you see EIC. So EIC is a work program, part of Horizon Europe, that exactly wants to help the scientists and the entrepreneurs, or the scientific entrepreneur, to get the know-how and enough money to go from the lab to the fab. And this is done in this quite complex scheme. You can see a lot of, on the x-axis, you see the technology risk. On the y-axis, you see, in a way, I don't read it anymore. The size of the investment, okay? You see there are different type of investment. EIC is a red one that is a governmental investment. Why I am pushing in this direction? Because today you will listen to 4 of our beneficiaries. That means these are companies, small, medium enterprises, headquartered in Europe, that received money through an evaluation of their proposal, exactly to go from the left side, so from the high risk, going further and further, ideally, to the NOC. You see these acronyms, that means ninth of a kind. That means they have got 9 times the production lines, for example. So it means they are in the market. But one of the requirements to bring a technology from the lab to the fab is, first of all, to have, let me say, a solution to a problem. The second one, for sure, is to have a team. And here today you will see CEO of companies, founders of companies, CTO of companies, where CEO is Chief Executive Officer, so the boss of a company, and CTO is Chief Technology Officer, so the mind, the scientific and technological mind. So first of all, to make from lab to fab, you need a very, very good team. Then obviously you need a lot of technological know-how, and you need also the support of the policy makers. And European Commission is one of the policy makers. And obviously you need to go through what we call the innovation journey. From the beginning to the end, one of your friend and enemy contemporary is the money. Deep tech are highly risk technologies where you need a lot of money and a lot of time to bring them from the lab to the fab. I give you a clear example. Take the lithium-ion batteries. It took 20 years from the first good enough when discovered, and he also got the Nobel Prize, up to 1992 when Sony sold the first lithium-ion battery. So 20 years is a time span for normally a deep tech. It can go obviously also 10 or 7 years, but it's a long time span. And you see here, you need to understand at each stage, you will need to look for money. The money can be from the governmental side, but can be also from the private side. And the EIC is a funding scheme that is trying to help to de-risk the private money. That means we give the money to the companies so that they will, let me say, develop their technology closer to the market, and it will be easier for them to get private money. Because in the end, let me say, the policy part, in this case the EIC, wants to enable the deep tech revolution. And the reason is quite easy. The more deep tech we will have, the more equitable society, the more, let me say, the higher quality of life we will have. So if we go, in this case, another peculiarity of the EIC is that we provide help to our companies, not only giving the money, but working on the contents. I am one of the program managers, and our job is to help the beneficiary to accelerate their innovation journey from the lab to the fab. Then we also provide external help through experts that will help our beneficiary to once again accelerate the innovation journey. And we mostly work, as I said before, in 3 areas. On the technology side, we help them in connecting with other scientists, worldwide experts. We help them working on the policy side to develop new policies. For example, in the renewable energy sources, one example, thanks to the feed-in tariff in many countries, the PV and the wind has been able to decrease so much the levelized cost of energy. So the policy in many of the clean tech can be an enabler. And last but not least, we help them in accelerating their innovation journey, in identifying the stakeholders, in look for the potential customers. We do this through different kinds of activities, let me say, studying, discussing with them, organizing events, connecting them with investors, with policymakers. And this is, let me say, a snapshot of the different type of investment that we do in companies. So in the green tech area, you see, we invest in companies in the energy storage, in the renewable energy sources. And these are some of the companies where we invested, from new kind of renewable energy sources. Today we will listen to a PV on a shot, and then we will see how to convert and to produce renewable chemicals, and then we will see how different technology in the energy storage field. To conclude, another aspect, I am program manager for advanced materials and technologies for energy and environmental sustainability, and an example of a deep tech is exactly the advanced materials. Consider that normally, nowadays, an enabling technology to accelerate the selection of advanced materials is artificial intelligence. This allows us to be faster in developing the innovation journey of advanced materials. But then it takes time to go, once again, from the lab to the fab. So now it's a real pleasure to give the floor to our beneficiaries. The first one is Andrea Mao de Ferro from company C2C New Cap. And please, now if you want to make questions to me, I'm more than happy to answer. Otherwise, I give the floor to Andrea. I hope I was able to give you a little bit of framework of what you will listen. So the idea today is to show you some of the beneficiaries that in a way got our money and are really trying to fight to bring their product to the market. So this is the idea of the next 4 speakers. Is there any question? No? So I give the floor to Andrea. Andrea, the floor is yours.
Thank you very much. Thank you, Francisco. Hello, everyone. It has been a quite busy day. I've been here in the morning. So let's go through this. My name is André Monteferro. I'm going to present you my company, C2C NewCap, and we are doing supercapacitor technology to power the future. We are a startup. We are a spin-off from University of Lisbon. We started in a 14 square meter facility lab. We have now 500 square meter facility lab where we operate a pilot manufacturing plant, and we have about 14-member team. Our core competences, sorry, the slides will have some issues because of PowerPoint, etc. So there's a picture there upside down, don't mind that. Our main core competences are really tech to market. We have a product already in the market, but we have a fundamental approach to supercapacitors. We build our own supercapacitors, so we've developed quite a lot of technologies for producing electrodes, for producing cells, to assemble cells in a stack of a module and to integrate the module in a system and put the system in an application, which I'll describe further down the road. And okay, and here's a picture of our company. So we are operating 3 main lines of work. The first one is automotive, is the one where we got the SME Phase 2 instrument and the accelerator. And this is already TRL9. It means that we have certified the product, it's in the market, we are selling, and we have happy customers and looking forward to growth this technology. I'll explain more about this later. The second one is stationary energy storage, and this is about TRL6, and we are planning to do installations, industrial installations in the north of Portugal and in an island in Azores. So they will integrate the grid of those locations. So this is not going to be just a lab testing. It's going to be in the grid, in the national grid. So we're looking for this. And PCAP is super interesting. This is the lowest TRL. This came up from a FET Open project. And we built this idea and we got the transition grant. And this is a supercapacitor that doesn't have any separators and it can operate above 200 degrees Celsius. Plus, it can it can charge and discharge more than once per second. Actually, it can do it 100 times per second. It means it works at 100 Hertz or above. So you can use this technology to replace electrolytic capacitors that generally fail at lower temperatures. So our idea is to build a supercapacitor that works at 100 Hertz and be able to work at 200 degrees Celsius for critical applications and applications that really need that stamina. So because we are in an EU event, I thought to talk a little bit about lead. Lead is a big motivation for me. I'm an environmental engineer. And we are focusing on heavy transportation sector, which has responsible for about 6% CO2 emissions. But no one is talking about lead, and lead is a toxic metal used in lead-acid batteries. It causes almost 1 million deaths per year globally, 1 million deaths. And